Elements are the fundamental building blocks of matter. They are substances that cannot be broken down into simpler substances by chemical means, and are characterized by their unique atomic structure. Each element is identified by a unique atomic number, which represents the number of protons in the nucleus of its atoms. The study of elements is a central focus of chemistry and is important in understanding the properties and behavior of matter. The periodic table of elements, developed by Dmitry Mendeleev in 1869, is a tool used to organize and categorize the known elements based on their chemical and physical properties. There are currently 118 known elements, with the most recently discovered being tenneson in 2010. These elements range in size from the smallest, hydrogen, which has just one proton and one electron, to the largest, oganesson, which has 118 protons and electrons. Elements can be classified into several categories based on their properties. The most commonly used classification is the division into metals, nonmetals, and metalloids. Metals are typically shiny, conductive, and malleable, while nonmetals are usually dull, non-conductive, and brittle. Metalloids have properties that are intermediate between those of metals and nonmetals. Elements can also be classified based on their electron configuration. The elements in the same column of the periodic table, also known as groups or families, have similar electron configurations and therefore similar chemical properties. For example, the elements in group 1, known as the alkali metals, have one valence electron and are highly reactive. The study of elements is essential in many areas of science, including chemistry, physics, and materials science. Scientists have been able to manipulate elements to create new materials with unique properties, such as superconductors and semiconductors. The discovery and understanding of elements has also led to advances in medicine, energy production, and many other fields. In summary, elements are fundamental building blocks of matter that cannot be broken down by chemical means. They are characterized by their unique atomic structure and are organized on the periodic table based on their properties. The study of elements is essential in many areas of science and has led to many important discoveries and advancements. Discovery of elements. The discovery of elements has a long history that dates back to ancient times. The ancient Greeks recognized that matter was made up of different substances, which they called elements. The elements that they recognized included earth, air, fire, and water. However, it was not until the 18th and 19th centuries that modern chemistry began to emerge, and scientists began to discover and study the elements in a more systematic way. The discovery of new elements was often driven by the development of new analytical techniques, such as spectroscopy and X-ray crystallography, which allowed scientists to detect and characterize the properties of elements that had previously been unknown. Characteristics of elements. Elements are the fundamental building blocks of matter, and they are defined by their unique atomic number, which is determined by the number of protons in the nucleus of an atom. Here are some characteristics of elements. Atomic structure. Each element has a unique atomic structure, which is determined by the number of protons, neutrons, and electrons in its atoms. Physical properties. Elements have unique physical properties such as melting point, boiling point, density, and conductivity, which are determined by their atomic structure. Chemical properties. Elements have unique chemical properties, which determine how they react with other elements and compounds. These properties include reactivity, acidity, and ability to form chemical bonds. Occurrence. Elements occur naturally in various forms such as minerals, rocks, and gases. Some elements are also synthesized in laboratories. Classification. Elements are classified into groups based on their properties. The periodic table of elements is a systematic way of organizing elements based on their atomic structure and properties. Isotopes. Some elements have different isotopes, which are atoms with the same number of protons but different numbers of neutrons. Isotopes have slightly different physical and chemical properties. Electronegativity. Elements have varying electronegativities, which determine how strongly they attract electrons in a chemical bond. Overall, the characteristics of elements are determined by their atomic structure, which dictates their physical and chemical properties. Study of elements. The study of elements involves a wide range of techniques and approaches, including both experimental and theoretical methods. One of the most important tools for studying elements is the periodic table, which organizes the elements based on their atomic structure and chemical properties. Chemists use a variety of techniques to study the properties of elements, including spectroscopy, mass spectrometry, and chromatography. These techniques allow scientists to measure the chemical and physical properties of elements, such as their melting point, boiling point, reactivity, and electronic structure. Theoretical approaches, such as quantum mechanics and molecular modeling, are also used to study the properties of elements. These techniques allow scientists to predict the behavior of elements based on their atomic structure and electronic properties. Properties of elements. Elements have a variety of properties, including physical, chemical, and atomic properties. Here are some of the key properties of elements. Atomic number. Each element is defined by its atomic number, which is the number of protons in the nucleus of an atom. Atomic mass. Elements have a unique atomic mass, which is determined by the number of protons and neutrons in the nucleus. Electronegativity. Elements have varying electronegativities, which determine how strongly they attract electrons in a chemical bond. Ionization energy. The ionization energy of an element is the amount of energy required to remove an electron from an atom. Elements with low ionization energies are more likely to form ions. Reactivity. Elements have varying reactivities, which determine how easily they react with other elements and compounds. Melting and boiling points. Elements have unique melting and boiling points, which are determined by their atomic structure and bonding. Density. Elements have varying densities, which determine how much mass is packed into a given volume. Conductivity. Some elements are good conductors of heat and electricity, while others are poor conductors. Radioactivity. Some elements are radioactive and undergo nuclear decay, emitting particles and energy. Oxidation states. Elements have different oxidation states or valences, which determine how many electrons they can gain or lose in a chemical reaction. Overall, the properties of elements are determined by their atomic structure, which dictates their physical and chemical behavior.